Welcome to Alberta Conservation Association's Harvest Your Own podcast, the resource for everything hunting, navigating through the field, the butcher shop, and the kitchen. Life is all about great food. Let's get started.
Welcome to the podcast. I'm your host, Brad Fenson, an avid outdoor enthusiast who has worked as a freelance journalist, photographer, and public speaker for over 3 decades. I have hunted, fished, and foraged all my life and hope to share my passion for the outdoors. Along the way, I want to encourage everyone to harvest wild proteins and enjoy the satisfaction of providing the next meal for your family. Our goal is to educate, entertain, and inspire individuals to get outdoors and create a connection between food, health, and your future meals. Welcome to Harvest Your Own. Today we have a special guest talking about, wildlife diseases and problems that we don't always know are out there. Sometimes they're invisible, but we have Dr. Margo Pybus, who's the Wildlife Disease Specialist in Alberta, and you've been here for quite a while. Welcome to the show.
Yes, I came to Alberta in 1978, figured I'd stay a few years, never left, like a lot of other people.
Yeah, it's a great place to call home. Great diversity and stuff, but what is a wildlife disease specialist? What do you do?
Well, my job is to oversee any aspect of wildlife disease. I focus mainly on birds and mammals. I try not to do fish. But it's a matter of tracking disease occurrence, providing input into policy, into programs, setting up surveillance programs, such as our chronic wasting disease surveillance program, or right now we're still monitoring avian influenza. And I love it because every day I learn something new. And we could get into 101 things that I've learned over the last little while. But certainly the one we want to talk about mainly today, as I understand it, is meningeal worm.
Yeah, it's something new in Alberta. You know, it's different. We've been dealing with CWD. Is it 22 or 23 years now? Well,
our first case was in 2005.
Yeah.
But we've been looking for it since 2001.
And we're fortunate because we're proactive in that way.
Exactly.
You know, a lot of other jurisdictions sort of close their eyes, look the other way, and hope it didn't happen. But I think Alberta's been on the forefront right from day one. And I know you and I have talked over the years because I've reported on this regularly. And, it's what hunters can do. They've played a big role in CWD management.
Mm-hmm. Yep, for sure they have. We wouldn't have the success of the program without the hunters and the landowners pitching in and giving us the samples that we can test so that we can see the patterns. And we've got a continuous, basically 25-year data set that nobody else has.
Right.
Nobody else has been able to do that. So other states and provinces are using our data and learning from it just the same as we're using it and applying it to our own research and management.
It's amazing what happens when you actually use science.
Yes. So that opens up a whole other ball of wax.
Yeah.
But we've been pretty fortunate, I think, in the wildlife disease side.
Yeah.
In that I, throughout my career, have had really, really good support. From pretty well from day one.
Yeah, and it's interesting because I've known you for most of your career, and there's never a dull moment. There's always something new. And one of the most memorable times that I saw you speak was at a dinner, a wild game dinner, and everyone just sat down to this nice roast beef dinner, and you started showing slides that this is a liver fluke, and this is this, and some people got a little squirmish and didn't want to have their dinner, but the rest of us laughed out loud because, that's as hunters, we often see these things and wonder what's going on, or we track it in the news. But, you've had a lot of different wildlife diseases and parasites and different things to deal with since 1978.
Right. Yeah. And actually, I was gonna. So the supper time time slot is one of my favorite time slots, particularly to do the parade of parasites,
right,
or things you might see or things you might not know were out there, but they're out there. They're part of the biodiversity of the province, et cetera, et cetera. Right. Yeah. I try not to put anybody off their supper, but yeah. But there are so many stories, and yes, you talk about different diseases. I mean, it's just. Wildlife diseases are never static, and a wildlife disease specialist always has something new to work on. So you can see waves of hantavirus coming through, of West Nile virus coming through, of avian influenza coming through. And it's just time and I forgot Lyme disease in the 80s. And it just opens the door. So my role is to help the system to help people, whether they're in government or out of government, policymakers, program managers, but also general public, and particularly have focused on the hunting and fishing audiences to help them understand what it is they're seeing, what's out there, whether or not there are very, very few that are harmful to people, but we need to know about those too. But we also need to know that the others aren't harmful. And so that's been a big part. I would say my job is 85% providing information and education to somebody, everywhere from kindergarten to politicians, which may not be different, but and everything in between.
Right. Well, it's an important role, and you do it well. And you've had an interesting career because it's ever changing. You know, I remember many years ago, it's probably going back 35 years. I was in Manitoba, and they had a big campaign asking people to look for deer that were acting strange, walking in circles, doing this. And it was meningeal brainworm. And I remember it clearly. I was a young hunter, not a lot of seasons under my belt, and I found it extremely interesting. I wanted to know more about it, and, that's what we're here to talk about today. You've got all these diseases and parasites we've talked about dealing with over the years, but the most recent one that has shown up in Alberta, at least we think it's recent, is meningeal brainworm.
Yeah. There's no doubt in my mind that it is recent. And just to fill in, so talk about a career coming full circle. So my master's supervisor at the University of Guelph years ago, when I was still in Ontario, Dr. Roy Anderson, in the mid and late 1960s, he began the story of meningeal worm. Ontario Natural Resources came to Dr. Anderson at the University of Guelph and said, "Why do we have all these sick moose?
Oh,
And we don't know what's going on. Can you help?" And so he was the one who first. So they called it moose sickness or moose neurologic disease.
Yep.
And Roy Anderson is the guy who put the picture together and said, this is white-tailed deer meningeal worm, and that's the effects it has in moose. So now I didn't work on meningeal worm for my master's when I was in Roy's lab, but meningeal worm was always on the table in the discussions and, reading all his papers. And then it actually comes back again into my career after I was started with Fish and Wildlife. And you may not know that in 1987, Alberta closed its borders to the importation of farmed cervids. That's right as game farming was starting to take off, and there were many, many elk outside the province that were probably going to come to farms in Alberta. And in conjunction with Dr. Bill Samuel at the University of Alberta, who also knows meningeal worm and was working on related parasites, we said, but elk may be potential carriers of meningeal worm. That's why, and so the border was closed because of meningeal worm concerns.
Right.
Everybody thinks that was CWD, but that precedes CWD.
Yeah, indeed.
So indeed, this parasite has been on Alberta's radar for over 40 years.
Wow.
And some of the presentations that I'm doing right now, I start off by saying this is an announcement that I've never wanted to make for the last 40 years, but
Right.
here it is.
Yeah, interesting, because right from early on in your education, you knew what to look for. You've read the papers, you knew what it was, you know what it can do. And
I
you
saw it in Ontario, and I never wanted to see it in Alberta.
Right, yeah. The rest of us don't either, but that's part of the story, I guess. So the parasite itself, tell us a little bit about it and its history.
Well, it's a roundworm parasite. The official term would be a nematode. And it's a native North American species. So it co-evolved with white-tailed deer and is currently found throughout eastern Canada and the U.S., and basically everything from the Atlantic out to about the 101 parallel, I think it is. But basically, it makes a living all through that area of Canada and the U.S. until it reaches the eastern edge of the Great Plains. And the environmental conditions, the dryness in the Great Plains or the prairies, like from Canada, from right on down through the U.S., has naturally stopped this parasite.
Interesting.
And we'll talk about the life cycle and you'll understand why.
Right.
But so that's it's been known, it's been in that area, as I say, co-evolved with whitetails in that area over millennia. So that's where it And in Canada, what would be the previous natural distribution peters out about the Saskatchewan-Manitoba border.
Yeah, and I always thought it was back that far as well.
Right. And interesting that you mentioned Manitoba and deer, because the other thing that completely overlies that distribution is the fact that there are no mule deer whatsoever in eastern Canada and the U.S., and it is directly because of meningeal worm. Mule deer are so susceptible to this parasite that they just can't maintain a population in areas where it builds up in whitetails.
Yeah, very interesting. So how is it distributed? Like if whitetail deer can have the worm and often have no effects from it, but other species do, they carry it, pass it on?
Yes, it's all coming from the whitetails. So I mentioned the coevolution between whitetails and this parasite. So they worked out the relationship, eons ago. So, but the key thing about meningeal worm is its very extensive migration once it gets into the ungulate host. So take whitetail deer, for example. Where should we start the life cycle? Let's start.
It's a circle, isn't it?
Yeah, well, cycles are...
Where to start?
Cycles are always circular. Let's start with, larvae of the parasite come out on the fecal pellets. So we'll start at the back end, and then we'll go to the front in a minute. So larvae on pellets onto the ground. These are attractive to terrestrial snails and slugs because there's good protein, there's good fiber, there's good food there. So as the snails and slugs pass over the infected pellets, the larvae penetrate into the foot of the snail or the slug. They develop for a little while and become an infectious stage, stay in the snail or slug, which then is on the ground vegetation, so that when a passing ungulate, like a white-tailed deer, is foraging, they take in the infected snails. So they take in the infective larvae. And this begins what I call, buckle down. This is Captain Nemo going to the center of the earth. Wow. Because it's really, really intricate. And thank God we had Dr. Anderson who worked this all out. So snails coming in are ingested. They go into the rumen. They're digested. The larvae come out of the snails, penetrate the abomasal wall, actually, not the rumen. So they penetrate the gut wall. They go across the abdominal cavity, pick up the peripheral nerves in the body wall, move dorsally towards the spine in the lumbar region. They actually penetrate into the spinal cord, but don't move. They just develop a little bit. Then they come out of the spinal cord and they move towards the head. So anyway, they're heading in the spinal column. They're moving alongside the cord all the way up to the brain, and they sit on the outside of the brain. Then you get males and females, so you're going to get fertilized eggs. The females are in the blood vessels around the brain, not in the brain. That's why I insist that this is meningeal worm. It's not brain worm.
Interesting.
Because it's not in the brain in the whitetails. It sits in that space between the outside of the brain and the inside of the skull, which is the meninges. So females put her tail into a blood vessel, releases eggs and larvae into the bloodstream. Where are they going to go? Well, they're going to get filtered out in the lungs, in the small capillaries of the lungs. So they come out of the blood vessels into the air spaces. Then they get coughed up. And you think, okay, they're on their way out. No. They're going to turn around. They come up the trachea, up the windpipe. They get swallowed. They go back down all the way through the digestive system, and that's how you get larvae coming out on the fecal pellets.
Wow.
So you can see it's a very intricate migration. It's a very extensive migration. And it's also migration that's really, really close to some very, very vital tissues in terms of the brain and the spinal cord. So for whitetails, it works just fine. Rarely causes any problems whatsoever. But if those infected snails and slugs are ingested by a moose, a mule deer, a caribou, a pronghorn, let's just stick with those for now. But anyway, by any other ungulate, that migration doesn't work so well. So when they get into the central nervous system, they often turn into and start tunneling through the spinal cord tissue itself, which is why one of the clinical signs, particularly in moose, is a posterior paralysis, because it's the worms in the lumbar region, which is the region right over the lower back.
Yep.
And they're damaging the nervous tissue, and it results in a paralysis. But if moose can survive that stage, the larvae come back out, they move up to the brain, and then, again, instead of staying on the outside of the brain, they will actually penetrate into the brain and start moving and, of course, causing damage to the brain. So that's where the fatal infections come in.
Oh, wow.
This podcast is produced for Harvest Your Own, a program dedicated to those who want to reconnect with food and health through their experiences outdoors. HarvestYourOwn.ca is a resource for individuals to learn more about hunting and the outdoors. There's information to get you started and ensure that your compass stays pointed in the right direction to be successful. Where's your next meal coming from?
And you got to wonder how the doctor that you had in Guelph could ever figure out that chain of events, because it is pretty intricate and microscopic for the most part.
Mm-hmm. Yeah, absolutely. Well, no, these are big worms.
Are they?
Yeah,
Okay.
They're relatively, once you get past the even the infective stage, you can see them. And when they start moving around in the central nervous system, they're leaving trails behind.
Oh,
so
wow.
you can actually see where they've been, or hemorrhages or tissue damage, that sort of thing.
Yeah. So when did it show up in Alberta, and how did you find out about it?
So our first cases were in the summer of 2025. So this was just last year. And it all resulted from our environmental protected areas have a caribou monitoring program underway. So they've got collars on caribou, and they noticed that some of their caribou were showing neurologic signs prior to them then being found dead in the field. And the first one is, okay, neurologic signs. Okay, this animal's got something wrong. But then we had 2 or 3, and they started thinking, okay, something is definitely going on here that they hadn't seen before. And so, long story short version, we started to think, like, meningeal worm wasn't even on our radar, because we've actually been looking for this parasite, as I say, on basically since 1987.
Wow.
It's been on our radar. We've always, I've always encouraged submission of neurologic clinical cases in moose or deer, so that we could look at them and try and find out what's going on. And we've never found meningeal worm. We've been looking for it. But with these multiple caribou, we started thinking, well, the list of options is pretty short. However, there are 2 other parasites that can sort of look like meningeal worms. So we ended up going the extra mile to get a definitive diagnosis. We ended up sending samples to a molecular lab in Tennessee with a good friend of mine he's Mr. PCR for meningeal worm in the U.S. And so he took our samples in. And while he's doing that, we also had another case come in. It was an indigenous harvester was seen a moose up at Fort McMurray, and he'd harvested the moose. But he went into the EPA office in Fort Mac and said, this moose just wasn't moving properly. Something didn't seem right. So we collected the head and thinking, we should check for CWD. And it's CWD negative. But while we're looking at the brain, we find meningeal worm larvae.
Wow.
Which we also sent to Tennessee. And long story short version, for August of last year, we had definitive confirmation that this was meningeal worm present. And all of these cases, it ended up we had 5 caribou and 1 moose cumulatively through that summer. And they were all in the same general vicinity, all west of Cold Lake and kind of south of Fort Mac. So then we started thinking, okay, where did it come from? How did it get here? That's your next question, I'll bet.
Yeah.
Okay. Oh, I can read your mind, Brad.
Well, I'm entranced with the story because it's pretty interesting to me.
So where did it come from? So we got in touch. Actually, in 2019, Saskatchewan environment had alerted us or told us that they were seeing more and more cases of meningeal worm because they hadn't seen meningeal worm either. Remember I said it was basically
Manitoba
stopped at
border.
the Saskatchewan-Manitoba border. But over the previous 10 years or so, they were looking at neurologic cases of moose and got to the same point where they admit or confirmed that it was meningeal worm. And the cases are all along the forest fringe.
Interesting.
So it wasn't in the prairies. It wasn't in that Great Plains was still not conducive to meningeal worm. But now they were seeing all of these cases on the forest fringe. So it basically does an end run through eastern and east central Saskatchewan.
Yeah.
And they had a neurologic case in a moose at Meadow Lake. Well, Meadow Lake's due east of Cold Lake.
It's right on the border almost.
Exactly.
Yeah.
So there's no question in my mind that meningeal worm had slowly made its move across Saskatchewan and got into the whitetails in the Cold Lake, Meadow Lake area, and that's how we got meningeal worm.
Wow. And it's interesting, there'll be a ton of questions we can never really answer. Is it because the deer population got so large, or is it because some of the deer are they move so much, or they could move so much? What actually makes it spread? This parasite can't move fast. It's got to be a fairly slow progression, but is there anything that can speed it up?
Yes, if you create absolutely perfect habitat for white-tailed deer, if you give whitetails the opportunity to increase in number, increase in abundance, and change their distribution so that you get more and more whitetails in that northern forest fringe, and that seems to be the avenue, because it sure isn't running across the landscape in the snails and slugs.
Right.
So it has to be the whitetails. And what we feel, these caribou and moose that we found in northeastern Alberta, what they're telling us is that it is already present in the local whitetails.
Right.
And is spilling over to the point where it's showing up in the neurologic cases with caribou and moose.
Wow. Part of the research in the future is maybe watching whitetails. Can you monitor it? If you were to take a sample of deer out of that area, good percentage of them going to have meningeal worm?
Well, that we don't know. So
right.
that's what we're working on now. So right away, Alberta never sits back and just watches these diseases come through. We want to know what's going on. And so we had the perfect opportunity in that we're already doing CWD surveillance in some of those units in the Cold Lake area. And we have our remote freezers where hunters can just drop off heads for CWD testing. So what we identified 4 freezers in particular. It was Cold Lake, Athabasca, Smoky Lake, and Lac La Biche. We had freezers out there for CWD.
Yep.
So what we did was when our drivers picked up heads out of those freezers, we put some flagging tape on them so that when they came to the lab, they got sampled for CWD, and then we put them back in the freezer. So now we're actually starting to pull them out because CWD is winding down. So we're just making our way through those whitetail heads to see if we can find meningeal worm in any of those.
I would imagine that you were anxious to get the CWD testing done to move on to the meningeal, just to see for yourself, because I know you love the science of it, and you love the bugs, slugs, and their life cycles and all the rest of it, but you want to dive further into it.
Yeah, absolutely. But we try our best. One of the challenges for the CWD program is getting results back in a timely manner, because hunters can shoot like 6,000 deer in the month of November and a little bit of December, but we can't possibly test 6,000 in 1 month or even 2 months.
Right.
So yes, we were keen to get going on it, but not about to abandon our flagship program of CWD. We go full out until we get those heads tested and done and results back to hunters as quickly as we can, which is not very quick, but it's as quickly as we can.
Right.
And so now we're saying, okay, guys, let's get going on these heads. We also had, in the meantime, there were 2 more neurologic cases in moose, one from Cold Lake, one from Fort Mac. So we got those heads that we're keen to look into. And as an additional part of the caribou monitoring program, back in 2024, the field crews picked up they picked up pellets off in that Cold Lake Fort Mac area and Cold Lake Air Weapons Range and through there. And they have already done the DNA, so they know which ones were caribou and which ones were deer. So we also had another source of information that we're just starting to analyze, is how many of those deer pellets, what proportion of them have meningeal worm larvae in them.
Oh, wow.
So it's a knowledge gap, but we have at least two avenues that we can jump on right away and at least get a little bit more information. And then while we're doing that, or the results from that, can then inform, well, what might be the next steps.
Interesting. Yeah, grass doesn't grow under your feet, and I'm glad that Alberta has the ability to react. That shows up here right away. You don't take it for granted. You know what it is. You take your time, you send it out, you confirm it with multiple tests, multiple labs. The science is what builds your program. Once you confirm it, you go back, start looking at other things that you can use to help identify the parasite and its life cycle and movement within that specific area. And it's interesting to note that hunters, once again, are playing an important role in it, because these hunter-harvested deer heads, even though sometimes we get frustrated because we have to wait a few months for information, it's very important information. 25 years of CWD data that other jurisdictions are now using, and now we have meningeal worm.
Well, and it's one of the core principles of my programs, or my approach to doing wildlife disease at all, is to try to get more value out of an animal that's already dead. Whether it's a roadkill, whether it's a hunter-harvest kill, whether it's found dead in the field, what can we learn? What can that animal tell us that we didn't know before? Do you want me to tell stories?
Sure.
Okay. So that goes back. That thought takes me back to the mid-1980s. It must have been earlier than that, because I was just starting with Fish and Wildlife. So the early 1980s, where the chief park warden at Banff National Park, this was before they had the fences along the Banff stretch of Highway 1. The chief park warden came and he said, Margo, I don't know you, but I'm told you're going to be interested in this. Each year they would get 1,000 dead elk
Holy cow.
hit on that highway, which is why they fenced it off. But this was before the fences. So Rick Cornelius came to me and said, we got 1,000 dead elk. Is there anything we can learn from them? So my job is to give voice to these dead critters. What can they teach us? What can I learn from them? What can we learn from them? And how can we use that knowledge to improve things for the elk that haven't been hit on the highways, as an example?
Interesting. Yeah, they're part of the investment overall, a large part of it.
Yes, yeah, for sure. Well, yeah, but it's respect to the dead critter too.
Absolutely.
It's respect and the value and trying to make the best of what we can literally to learn. One of my other guiding principles was, if you don't learn something, why'd you get out of bed this morning, So constantly wanting to learn.
Yeah. They're the best days when you learn something, right?
Yeah, so we gave voice to those 1,000 dead elk, and they told us a whole lot about giant liver fluke.
Oh, wow, interesting.
Yeah, read the paper.
Yeah. Well, I remember the work you did on it, because some of that information was used in Elk Island National Park with the liver flukes there as well, even though it was mostly in moose, but also in elk, I believe.
Yeah, well, it started off in elk.
Right.
Yeah, well, there again. So 1987, I was a grad student, U of A. No, it couldn't have been 87 because that was wrong. 1982, there you go. 1982 as a grad student. Bill Samuel had been working closely with Elk Island National Park on winter ticks and moose, and doing research on tick survivals and moose survivals, etc. And we got a moose in, and, well, I wanted to see what was inside. So I looked at the liver of that moose, and I found giant liver fluke. And I go running down the hallway, Dr. Samuel, I got giant liver fluke out of Elk Island. And he said, no, you didn't. He said, no, we've looked for liver flukes. It's not there. And I said, well... I had worked with Ontario Natural Resources. I knew what liver fluke in white-tailed deer, road-killed white-tailed deer in Ontario. And I said, come with me.
Yeah, come and have a look.
And I grabbed Dr. Holmes at the same time, the other parasitologist, because he said the same thing. They'd looked for it in Elk Island and they never found it. So I took the two of them down to my lab and showed them the liver I was working on, and they said, oh my God, she's right.
Right, giant liver fluke.
Yeah, so liver fluke would be maintained on the north side of Elk Island. It's maintained in the elk population, and built up to the point where it's a slightly different life cycle. It goes through aquatic snails, and the larvae insist on vegetation, and then anything that eats contaminated vegetation can get the infected larvae. So as we got more and more liver flukes in elk, more of it showed up on the vegetation. So now you get more and more moose that are ingesting giant liver fluke, and they don't do well, similar to meningeal worm. And I can tell you why in a minute if you want that. Yep. But the liver fluke can cause fatal infections in moose. Rarely, if ever, causes fatal infection. Whitetail. Does that sound familiar pattern?
Yeah.
So sure enough, Parks Canada set up a research project. We put collars on female moose on the north side of the park and also on the south side, because of course there's a 4-lane highway and 2 big fences that separate north from south. We knew liver flukes were in the north and they were not in the south.
Oh, wow.
And over the period, our collared moose in the north died at a significantly greater rate, and all of them had giant liver fluke, as opposed to the collared cow moose on the south side of the park that didn't have giant liver fluke and had a much, much higher, significantly higher survival rate.
Interesting. Yeah, it's interesting to look at all this stuff. Now, where do you get most of your sightings and stuff? There's obviously researchers that are looking at the caribou that told you about their observations and what the neurological problems were with the caribou. You had a hunter turn in things, but that comes through the officers and our enforcement people in the field. I am guessing they get called out to different things, and their first call is, Margo, I got something interesting here.
Yeah, to some extent. As a matter of fact, I had one of those calls early this morning with the officer out of Bakerville saying, hey, I got this. What do you think it is? In general, I go back to my statement earlier that it's education and information and trying to inform, but also to receive reports of anything that's unusual or strange, or we talk about clusters of mortality. Like a single dead owl doesn't really get me excited, but when somebody reports that they've got 2 dead adults and 3 owlets at the base of the same tree, and then we put 2 and 2 together and confirm that that's actually high path avian influenza. That was the spring of 2022 when the avian influenza virus changed to something that started to kill dead birds, and it's supposed to be an avian influenza. It's not supposed to kill wild birds.
Right.
It kills domestic birds because they've never seen it before, but the wild birds all around the globe are carrying strains of avian influenza, and it's not supposed to kill them.
Right.
Until recent. It's
interesting. Avian influenza. There's been people look at the flu and viruses differently since we've had COVID. They either are paranoid of them or they brush them off like they're nothing. But avian influenza is there. It does have an impact on our wild bird populations, obviously on our farmed fowl. They've had a major impact as well. But recently, specialists like yourself have actually seen where it's infected dogs, hunting dogs.
No.
No?
Not hunting dogs. One case in one dog that was immunocompromised and had medical issues for quite some time.
There's always an explanation.
Exactly. So that individual dog was more susceptible to the virus. But dogs in general, and in fact canids in general, really interesting component of this high-path avian influenza that we've learned over the last 3 years, is skunks are exquisitely susceptible.
Oh, wow.
Well, that makes sense to me because mustelids, members of the weasel family, which includes the skunks and the mink, are exquisitely susceptible to encephalitis viruses, or to viruses that can cause damage to their brain is a better way to say it.
Yep.
So when in the spring migration of 2022, when we estimated maybe 100,000 dead snow geese on the ground in central Alberta, and started getting calls about skunks acting strange. Well, when you get reports of strange behavior in a skunk, your first thought is always rabies.
Right.
However, Alberta has a wonderful rabies program, and we've worked at it for decades. We haven't had a rabid skunk in Alberta since 1993.
I remember John Gunson's talks about skunks and all his encounters with them.
Right. But there again, Alberta not being willing to just accept this virus as coming new into the province and becoming established, we have controlled that disease from day one, going back into the 1950s when it first came down out of the Arctic from the Arctic foxes. Anyway, long story, short version, we do not have terrestrial rabies established anywhere in the province. We're one of the few jurisdictions that can say that.
Wow, that's significant.
And yes.
Yeah.
So when I got a call about a neurologic skunk, I said, well, we should probably send that in for rabies because we do test them. That's how we know they're not positive, because you don't know if you don't test them. But within a week, I had 9 calls, Brad, about skunks that were either found dead or acting strange. And so now I've got a cluster of unusual mortality. In the same area where we had all these dead snow geese, which we had already confirmed had died of avian influenza. So I went to the lab. All of our testing is done in conjunction with the Alberta Agriculture diagnostic labs. So I approached my ag colleagues in the lab in particular and said, I'd like to test, my spider senses tell me we should test these skunks for avian influenza. And again, they laughed. They said, Margo, it's called avian influenza.
Right.
I said, yeah, but just humor me.
You're right.
Humor me. So they tested him, and it glowed in the dark for high-path avian influenza. And over that spring migration, we got reports and confirmation of avian influenza. We believe at least 80 skunks died from eating contaminated snow geese that had died of avian influenza.
That's just the ones you could see or find.
Correct.
Yeah.
Yeah, but they were pretty visible because this was early. This was May. Producers were out on the land, so they're working up the land, getting ready to do crops and whatever. The snow had melted by then, and they look out across this flat cropland, and they see all these white lumps, which were the snow geese. And similarly, while they're out working up the land, they were finding dead skunks, or they were seeing strange acting skunks, or the skunks were in the ditch while they're driving from the home site out to the field, sort of thing. So yeah, it's a minimum number of 80 dead skunks for sure. But so why did I get into that? Because mustelids are susceptible to avian influenzas. At the same time, we had a couple of reports of young foxes, like fox pups, that were showing neurologic signs. And similarly, Ontario was starting to report them by then, and I believe Saskatchewan may have had one. But anyway, so they're also avian influenza positive and fatal infections in the pups, but not in the adults. Nobody has yet... I still think to this day we haven't had a positive adult fox. And for all those carcasses laying on the ground, you got to believe coyotes were eating them.
Oh, absolutely.
Not a single case of avian influenza in a coyote. So that leads me to suggest that there's a sliding scale of susceptibility. The mustelids, the skunks, the mink, the weasels are susceptible to this virus. Foxes, when they're young, but we know youngsters have incomplete immune systems. So it makes sense that it was going to affect the youngsters, but by the time they're older, but they're adults, their immune system is now sufficient that it can fight off the virus. And the coyotes seem to have immunity from day one.
For almost everything.
Yeah, except for mange. But so that leads me to believe that because the other thing that I do that I was taught to do is to look for patterns. An individual doesn't really mean an awful lot, but look for patterns. If you've got multiple individuals,
then it's a story.
Then you've got a pattern. You've got some underlying thread that connects them. So the thread to me is that if the canids have this innate resistance to avian influenza, then it makes sense that we don't see cases in hunting dogs because they're a canid.
Yep.
And they're basically immune to it, and naturally immune to it, except when you've got an immunocompromised individual that's got other medical issues. So
it all makes sense.
Well, I try my best to make sense.
Well, I don't think you'd have it any other way.
This podcast was made possible by Alberta Conservation Association and the Harvest Your Own community. If you're interested in harvesting your own food, there's a comprehensive collection of information to gain insight and knowledge. Head to the field, harvest your own protein, prepare it, and taste the results. HarvestYourOwn.ca is a library of information from getting started and geared up to processing, butchering, and cooking wild game to make the connection between health and food.
Now, let's go back to meningeal worm for a minute. What's it mean to Alberta wildlife? Is it going to be fairly isolated because of the habitat and dry conditions? You know, we talked about that originally, so I'm going to come back to it.
Sure. Yes, I don't think meningeal worm is ever going to establish in the dry areas that it has been naturally excluded from. However, where it's making a living, where it's able to sustain a population, is in the northern forest fringe. Now, back in I keep going into history, right? Because this parasite has followed my career. It's followed me all along and taught me a lot. So in 1996, we actually did a risk assessment, a full-blown risk evaluation of whether or not meningeal worm would be able to exist in Alberta. Remember I said earlier on that the border was closed?
Right.
Because we had concerns about meningeal worm. So we did experimental infections and proved that elk, indeed, some of them will die with meningeal worm, but others will survive and can pass larvae. So they are potentially a carrier in that sense. So we said, okay, the other thing we need to know is if it was carried into Alberta, would it be able to establish here? Would it persist? And we found that there are lots beyond the dry prairie regions that there are many, many parts of Alberta that have suitable environmental conditions to support the parasite, to support meningeal worm. And we know whitetails are here. We know the snails and slugs are here. The assessment tells us that the environmental conditions are suitable if it ever got here. The only thing missing was the parasite, was P. tenuis itself.
Wow. And
now we've got P. tenuis here. So what's it going to do? The risk assessment tells us that there isn't anything that's going to limit it naturally. That it will now go wherever the whitetails go. And when when other ungulate species encounter it, like moose, like the neurologic moose,
yep.
Caribou are exquisitely susceptible to meningeal worm, fatal infections. Mule deer, I'm not suggesting that it's going to wipe out mule deer, even though it has precluded mule deer from anything in the east. They just can't exist in the face of this parasite. But certainly there's going to be increased mortality, increased clinical signs, but it's going to be a slow-moving, incremental change at an ecosystem level. It's going to change. There's still caribou in Ontario, but they're in the northern part. They're not necessarily overlapping where there are heavy and high infections in white-tailed deer. Similarly, moose they can't live sympatric. They can't overlap with heavily infected whitetails and maintain a population. It's been identified, they're called refugia for moose. So the moose are existing in a small basic island of habitat that doesn't have a lot of whitetails in it because that keeps them away from meningeal worm.
Interesting.
But if they get out into the area where meningeal worm is more common, then the numbers decline at a population level.
The poor old moose. It's been interesting to watch their changes in Alberta. We never used to have them in the parkland or the farm country or the prairie, and then we saw a huge blow up in I believe it was the 80s where they really showed up and expanded, and insurance claims went up, seasons came out, harvest rates went up. I think our harvest went up higher in the farm country and parkland than it was in all of the boreal forest. But now they have a creature to deal with that's going to change the tide a little bit.
Mm-hmm. Yep, for sure. Yeah, no, Ron Bjorgi actually documented that. I think it was about 1977 where they started to document the occurrence of moose in the prairie park or in the parkland. Yeah. And then since then they've turned south and now established all the way down to Medicine Hat. Where I get calls from Drumheller, and they're heat stress moose on the side of the Red Deer River. Saying, well, you really shouldn't be here, guys, but they're there.
Yeah, they somehow eked out a living somewhere.
So this is the other one of my favorite stories. So you mentioned moose. So why are moose? Why do moose get hit so hard by these parasites? We've talked about winter ticks. We've talked about giant liver fluke. We talked about meningeal worm.
Because they have been here a shorter length of time.
There you go. See, you've got the answer. Yes, exactly. Moose are relatively recent. They've only been here 14,000 years.
Right.
So they've just encountering these North American parasites, because winter ticks, liver flukes, and meningeal worm all evolved in North America. Moose evolved over in Asia. So they've just come across the Maryland Bridge. And they haven't learned how to live with these North American parasites.
Yeah.
So that was good. Yeah, I'm glad you got that answer. So where do elk fit in?
Oh, interesting, because they were more native, and maybe that's why they can survive it, and moose can't. Don't know for sure.
Put your time scale back to work.
Yeah, well, they were more of a prairie creature where the meningeal worm wasn't, I believe.
But when are elk native to North America?
I don't know the timeline on it.
No, they're not native. They came from Asia.
They did too?
They also came from Asia, but they came 75,000 years ago.
Before the moose.
Long before the moose.
Yeah.
And I mean, they didn't immediately start to interact with meningeal worm and liver flukes 75,000 years ago, but eventually they've had a much longer time overlapping with whitetails, overlapping with these North American parasites. And so the situation with elk, remember I said meningeal worm, we did the experimental infections.
Yeah.
Some of them are fatal infections and some of them are not. And you see the same thing with winter ticks on an elk. They get them, they scratch away at them, and it doesn't. But it doesn't lead to any fatal infections. It doesn't drain their energy the way it does with
the poor old moose,
big dumb moose. Yeah, the new arrival.
Right.
And so all three of the parasites have the same pattern in those three hosts, depending on the length of time that they have spent with that particular host. So it evolved with whitetails, everything's fine. The elk have been here 75,000 years, and sometimes it works for the elk's behavior, in the elk's favor.
Yep.
Sometimes it works in the parasite's favor. And moose, here the shortest amount of time, they just can't live with these guys.
They get hit hard.
Yeah, they get hit hard.
Interesting. Well, I find this stuff very fascinating, and every time we get together, I think I ask you more questions than you probably get at your dinners that you speak at. But what can hunters do? If we're out in the field, whether you're a conservation-minded individual, a bird watcher, a hunter, you see an animal that's acting a little strange, what do you do?
Call a Fish and Wildlife office. Don't call me. No. Call a Fish and Wildlife. No, report it to somebody. Whether it's the Report a Poacher hotline or actually I'm getting quite a few calls being forwarded now coming through Alberta Agriculture.
Right.
Yeah, so our government network is such that when those calls come in, regardless of which department or where they're coming from, chances are they're going to end up coming across my desk at some point if it involves wildlife that's acting strange and it might possibly be a disease situation.
Right.
And that is the other part. You mentioned we talked about, what have we done with regards to meningeal worm? So I mentioned we've got these heads to look through, we've got deer pellets to look through, but we also initiated a communications campaign. We've gone out and we've talked to people. We've talked to stakeholders. We've talked to the Wildlife Federation. We've talked to APOS. We've talked to, I'm on the road on Thursday. We're going to go to the Invasive Species Conference and tell them about this new entity that we have on the landscape in Alberta. And so it's getting, we've talked to the First Nations outreach, to the Métis groups saying, and to the industry. So these folks are all our eyes in the field. So if you see something that looks really strange,
don't ignore it.
Don't ignore it. Report it. If it's way back in a remote area, we may not be able to do anything about it, but we can at least log it in as an occurrence of a strange acting moose or caribou or an elk. And in situations where we can actually collect at least the head, we can go looking for and either determine whether it is meningeal worm or is it something else.
Yeah, it's interesting because nowadays, cell phones allow people to take pictures, shoot a video. It actually gives you a location where the photo was taken. It's a lot of information that you can get. The head's the most important, of course, because you need to verify things, but a lot of information just like when you first heard what's happening with the caribou, I'm sure you've got certain signals that go off in your brain. You're going to check for this, and this. It's what you've done your whole life. It's what you're trained to look for, and people can't always identify it, but we can sure help to point in the direction of where to look for it or keep an eye out for it on the landscape.
Yeah, for sure. And you're right bang on. My job got a whole lot easier when everybody had a phone in their pocket that got a camera in it.
Yeah.
And so prior to that, I would get a hunter call and say, well, there's this big yellow thing, and it looks like a worm.
Yeah.
And now I can say, well, can you shoot me a picture? And I take a look at it and say, well, it's not really, in my mind, it's not that big and it's not yellow, it's creamy, which is different from being yellow. and so, the pictures I get, that's one of my joys of hunting seasons, is just waiting to see what am I going to learn next? What's going to come in that I've never seen before? Or what's coming in that, I know exactly what that is. Yeah. And speaking of which, we do actually have over 50 wildlife disease fact sheets on our web pages,
right.
and I've focused in on the common things that hunters and fishermen, or naturalists or bird watchers, the common things that you might see in the field, and you might wonder what it is.
Right.
So the information's all laid out there.
Wow, we've covered a lot of ground here in a short time, but I appreciate having you in Alberta to work on these things. Your knowledge and background have been, I think, put us ahead of other jurisdictions by far. Whether you're talking about CWD or rabies control and all these things that you've worked on over the years, it's I would have to think that it's made a very rewarding career, because that's what you're looking for, is the strange, unusual, and figuring out the puzzles.
Yeah, yes and no, Brad. Yeah, and I think you live the same thing too. So it's not a career, it's a life.
Yeah, lifestyle.
This is all part of me. This is my jam. This is what, looking out the window, and one of my best ghost moose pictures, meaning a moose that's been heavily infested with winter ticks. It's broken all his hair off, so now he's a white moose instead of a black moose. And they call them ghost moose. One of my best pictures was taken out my kitchen window.
Wow.
And so, but to be able to see that, and that's what keeps me going, is because it's not a career. Sure as heck, nobody becomes a biologist for the money, that's for sure.
Right.
You're not going to get rich at it, but you get rich in so many other ways.
Right.
It won't put a whole lot of money in your pocket, but you'll be far richer in the long run.
You can't buy passion.
No.
It's been it's always interesting to chat with you, and I am very glad that we have you in Alberta to work on these things. We're going to keep in touch about a bunch of these things. We've been following CWD for a year. We'll follow the meningeal worm, avian influenza, liver flukes, and anything else. I'd encourage people to look at the wildlife disease pamphlets that you've developed and have available to people. I've read through them over the years, and I always find them interesting, because of the passion of the outdoors and wildlife and wanting to know more about everything. So,
well, thanks for the opportunity for me to come and tell you my stories.
Yes, well,
just
thank
a
you.
small portion of my stories, anyway.
I think we could talk for hours, and I'd be listening intently to the stories because they are very interesting. So, thanks for sharing with our listeners and helping to keep the general public in Alberta informed about what's going on.
No problem. Thank you for the opportunity.
We hope to inspire people to reconnect with nature and appreciate where your food comes from by harvesting your own. For more information on getting started or to learn specifics about the Field to Fork experience, visit harvestyourown.ca and follow on Facebook and Instagram. Check back often for new material, recipes, and videos that are posted regularly. Please subscribe to Harvest Your Own podcast and take the time to rate and review the show to help us build a dedicated core of passionate hunters as our regular audience. Until next time, embrace the outdoors and all it has to offer. Thanks for joining us.